Okay, so today in class we talked about solving systems of equations with three variables. So you're going to have three equations, three unknowns. The first two ask us to tell whether or not the order triple is a solution of the system. In order to tell if it's a solution, you have to substitute in for x, y, and z and make sure that it fits in all three equations. In order for it to be a solution, it has to work in both equation 1, equation 2, and equation 3. So if I take 1 and substitute it in for x in the first equation, I have negative 1 plus y, which is 2, plus z, which is negative 4. And I'm trying to decide whether or not that equals negative 3. Well, negative 1 plus 2 is 1, minus 4 is negative 3. So it actually does work for this one. For the second one, I'm doing 4 times 1, which is 4, minus 2, which is y, plus 4 times negative 4, which is negative 16. Probably should write that with a plus and a minus. So that would be minus 16. And we're trying to see if that equals negative 14. Well, 4 minus 2 is negative 2. 4 minus 2 is 2. Minus 16 is negative 14, which means that it does work. The last one, we're going to do 1 plus 2 times 2, if I'm putting the 2 in for y, which is 4, minus a negative 4, and minus a negative becomes positive 4, and we're trying to see if that equals 9. 1 plus 4 is 5, plus 4 is 9. So since it works for all three, this is a solution to that system of equations. For the next one, we're going to put a negative 1 in for x, a 5 in for y, and a 3 in for z. So for the first equation, 4 times negative 1 is negative 4, plus y, which is 5, plus 3 times 3, which is 9, and we're trying to see if that equals 7. Well, negative 4 plus 5 is positive 1, plus 9 is 10, so it does not work for the first one, which means we are done. We don't have to keep going. If it doesn't work for one, then it's not a solution to the system. Okay, for 3, 4, 5, and 6, they're asking you to solve using matrices, so we're going to make the matrix first, and then we're going to use our calculator to actually find the solution. So they all need to be in the proper order, x, y, z, equals, and then the constant. And you just use the coefficients that are in front of the letters to make your matrix. So my first row is 5, negative 1, negative 2, negative 6. Second row, 1, 3, 4, 16. And my last row is 2, negative 4, 1, and negative 15. Okay, so I get my calculator up. Here. All right, turn it on. We're going to go to second matrix, arrow to the right, go up to RREF 5 times. When we do alpha zoom this time, we need it to be a 3 by 4 because we have 3 rows and we have 4 columns. Okay, notice 3 rows, 4 columns. So we're going to hit OK. And now we're going to type in our answers, or our matrix. So hit enter. Okay, so notice that on this one, we were looking in the solution for there to be basically a diagonal of 1s with zeros all around it. And then the last column is our solution. So in this particular one, we had 1, 0, 0, and notice there were 1s and then zeros, and it made like a triangle. And then for our solution, there was 0, 4, 1. So this was 0, this was 4, and this was 1. Now, our solution is the last column. If there's a solution, then this part right here will look like this, and it will be a diagonal of 1s. Okay, if it looks like that with zeros, then your solution is going to be 0, 4, 1, which means this is x, this is y, and this is z. That's how we type them in. All right, for the next one, we make our matrix. It's going to be 1, 1, 1, negative 8, 3, 3, 2, negative 21. Negative 1, 2, negative 2, 11. Okay, and type that into the calculator. And I'm going to use the, I'm going to go ahead and cheat a little. I'm going to go back up there and hit enter, and that's going to build my matrix again so that this time I can just input the numbers again and not have to go through all the steps. So 1, 1, 1, negative 8, 3, negative 3, 2, negative 21, negative 1, 2, negative 2, 11. Don't forget to delete any that you don't need. So make sure that when you hit enter, it looks the way that you want it to look. So again, we have our diagonal of ones with all the zeros, and so our last column is going to be our solution. So 1, 0, 0, 0, 0, and then our solution is negative 5, 0, negative 3. So our solution is x is negative 5, y is 0, and z is negative 3. Okay, next page. All right, this time all the systems are not in the correct form. We have to have x and y, then z. So our very first equation is fine. We can make 3, negative 1, 1, and 25. That's good. But our second one is not correct. So what I'm going to do is subtract the x to the other side. And yes, I know it'll be on the other side, but that's okay. We can make this negative x plus 2y minus 3z, and we'll just put the equals negative 17 on that side. So this will be negative 1, 2, negative 3, and negative 17. For the bottom one, I'm going to go ahead and add y and add z. So this is going to be plus x, add x, not z. So I'm going to add y and add x. And so on this side, it's going to be x plus y plus z equals a positive 21. So that's 21. Okay, if we input that into our calculator, excuse me. So we have 3, negative 1, 1, and 5, negative 1, 2, negative 3, negative 17. 1, 1, 21. Okay, so we get, again, 8, 6, and 7. 1, 1, 1, 8, 6, 7. So x is equal to 8, y is 6, and z is 7. All right, for the last one, I'm going to go ahead and add x to the right or the left side. So I'm going to get x minus y plus z equals negative 3. Over here, I'm going to add 5z to this side. So that's going to be 2x minus y plus 5z equals 4. And then for this one, I'm going to add 2y to both sides. And make sure you put that in between the x and the z. Don't put it at the end. So 4x plus 2y minus z equals 2. They all need to be x, y, z. So now our system is 1, negative 1, 1, negative 3, 3, and 2, negative 1, 5, 4, and 4, 2, negative 1, 2. Guess I'm putting these in the wrong box. Oops. Okay, let's get the solution. Okay, 1, negative 1, 1, negative 3, 2, negative 1, 5, 3, 4, and 4, 2, negative 1, 2. Okay, that's what we want. Hit enter. And we got negative 1, 4, and 2. So our solution is negative 1, 4,